Hello data lovers. So welcome back to another amazing tech video for the data engineering. So from last couple of weeks, I was planning to create an end-to-end project around the streaming data pipelines, and I was working on that. And personally speaking, based on my experience, and if you are aspiring data engineer and you have little bit experience in that field, I and you both can relate that how challenging these streaming data pipelines are. So if we are building these streaming pipeline from the scratch, then we all know that how interesting it is. Lots of learnings are involved. On the other hand, building this streaming pipeline is definitely going to be challenging, and that is the actual beauty of it. And in last few years, I appeared in multiple tech interviews, including top tech giant companies, and their expectation from the data engineers nowadays to be good at building the streaming data pipeline. So if you are also starting your career in the data engineering domain, then this is something you should definitely have in your portfolio. So in today's video, we will be creating an end-to-end streaming data pipeline for the Wikipedia data, and we'll be doing the user data analysis within few minutes without doing any extensive coding. And for that one, you need to watch this video till the very end. And before that one, you can also let me know in the comment section, what do you like the most, building batch data pipeline or real-time streaming data pipeline? So if you talk about building streaming data pipeline in current tech industry, so you would have used common tech stack like Kafka, AWS Kinesis, then for processing Spark structured streaming and Apache Flink, and then dumping that data into the downstream system. So one thing is pretty much clear, that at least somebody has to have a really good understanding of building these streaming data pipelines, along with that special skill set with respect to these common tool and tech stack and the programming. And that is the reason organization need to hire more and more resources. But as we are growing in the technology and improving the development life cycle of streaming data pipelines, there are many platforms who have started focusing on low code or no code ETL pipeline. And that is the reason in the recent time, I have also started exploring these type of platforms. And recently I got to know about this amazing platform 𝗏𝗏𝗏, which is especially designed to create a streaming data pipeline within few clicks. And recently they have built a feature of SQL streaming, which is definitely going to be the game changer in the industry, because it would be much more adaptable, and a data engineer, a data scientist, even including data analysts and business analysts, they can also create these sophisticated streaming data pipeline without any prior knowledge in the coding or without doing any extensive coding. So let's explore this platform end to end and build this streaming data pipeline and explore the world of SQL streaming. Alright, so here is the 𝗏𝗏𝗏𝗏 platform, and I will provide all the important links in the description, including the documentation, which you can refer to build this data pipeline as well. So here you can create a free account. I already have mine. So this is how you will log in into the platform, and now you are completely free to play around it. And we are not free, we will be building that Wikipedia data pipeline. So this is the typical flow, and this is how pipelines will look like into this platform. And this entire pipeline is actually known as a flow, where it will have the sources. So these sources typically going to be those type of platforms which can generate the CDC event or generating the data in the streaming manner. It could be an API, it could be an MySQL database which is generating CDC event, or any other type of data source. Then in between we will be doing the processing. We will have our logic of doing this stream processing, which will be written in the SQL, and after doing that transformation, it can be dumped into different type of destination as well, including the data warehousing services and another database or persistent file systems, and even the Google Sheet as well. So in 𝗏𝗏𝗏𝗏 platform, this is going to be a 3-step process. First, we will create this capture. Capture is just like setting up a connection with your source and defining which data object or table or any particular entity in that source from which we are going to consume that data. So that will actually set up a streaming connection, and then those events or that data will start flowing into the 𝗏𝗏𝗏𝗏 system. So whatever data will get captured here, it will be stored as a collection on the 𝗏𝗏𝗏𝗏 platform itself. And then we basically need to create this transformation part where the entire logic will be written. And third step would be this materialization part. This is more like just storing or dumping the transform data into the downstream system. So as soon as you log in and you go to the collection, then you will be able to see this sample data already generated. If not, then what you can do, you can simply click on this 𝗶 capture part. Then maybe after a few seconds that sample data will be available in this collection. But if you also want to see that how we create capture or we set up this streaming pipeline with any other data source, so you can click on capture and there you will get a list of all available type of sources. So for an example, we want to set up a connection with Postgres. So you can simply connect here. You can provide the server details, the user password and the database name, and you can set up advanced settings, and then your streaming pipeline is set up, streaming pipelines just to consume data from the sources, and whatever data is being captured from that specified table entity, that will be available in the collection. So for this project, you can already see we have set up this streaming connection with Wikipedia API, and from here we can see the details, and here you can basically see the stream setup. So this real-time data will be captured here and will be available as a collection, which I already told you, and this will be on the S3 platform itself, whatever data is coming, because this platform can handle that data on scale for the processing. So if I click on this one and show you the details, so this is how we are actually getting the data. I hope you can compare it with the data you are getting in the Kafka topic, which will have a key and a complete value. So on Wikipedia, we all know that every second tons of changes are happening. A user can basically visit a Wikipedia article n number of times and make some edits, changes. So all those activities will be done here. So the use case which we are going to solve here, we will generate the user level matrices, like how many times a number visited and how many number of times it made the changes, all those type of matrices. So now this is the streaming data or our source data, which is already available here. So the next task for us will be creating this transformation logic, which will be written in the SQL. For this particular use case, I can even skip this transformation part, because try to imagine those streaming solutions or the use cases where the data or the CDC events which are getting generated on the left hand side, or basically you can say the data source side, most of the times you might only consuming those real-time streaming events or the CDC events and just trying to dump it into any downstream system. So if you have those kind of plain use cases where no transformation or any sort of aggregations are required, then without even creating this transformation part, I can go to this materialization part, and here we can create this materialization. As soon as the incoming data is available inside the collections part, it is available here for the consumption, and from here we can move to any particular destination, any file system, any other database, or any kind of streaming framework. But to demonstrate this use case, I definitely like the new feature which introduced by ESTUARY, that is SQL streaming. And that is why I will not do the plain data movement from source to destination. Let's add some transformation here and try to manipulate the data which we are getting from the Wikipedia data API. So let's start with the transformation part. Click here. How we are going to do it? We need that collection, means where we are getting our data. So we will be picking this one, recent changes sampled. So collection selected, and then SQL, and here we can basically provide the project name. So Wikipedia data analysis. Let's click on this, proceed to Git pod. So once you click on this one, so this entire code process will be actually done on the lab environment. So this Git pod is sort of that you can say lab environment where Visual Studio Code workspace will be there, and we will be coding all the things, and we will be executing this pipeline there itself. So if you do not have these type of accounts, let's say GitHub, Gitpod, then once you are doing it for the very first time, it will ask to do so, and you can do it accordingly. So after clicking on that one, you can see the new workspace information will be here, and here you can click on the continue. All right, so here you can see our project setup, and inside this one you can see flow.yaml, and these are two files which got created. I will talk about it, what it actually means. So first look at this flow.yaml. So what kind of information this flow.yaml contains? As I said, this is going to be a no code ETL platform, so most of the things will be configuration based here. So configuration based means what data we are consuming from the source, what column we will be using as a key, and then we also need to define our logic into this file. So if you look at this transform section, so here we need to focus two things, this part and this part. So what migration part actually means here, so think about a example, right? Streaming data pipeline where you just want to keep on taking the customer counts which are visiting a mall or a particular restaurant. So let's say there is a machine or device which is capturing those users, and even a particular customer might enter multiple times in a day into that restaurant. So how we are going to capture it? So for that one, that customer might have a exclusive customer ID that will be treated as a key, and every time we will keep on adding +1 so that we can take a total count of it. So if we want to get the total count and that data is getting captured and processed in the streaming way, so we should have a knowledge of the historical value as well. Means what is the total count we have seen so far. So if we want to do these kind of things, and this is common even if you build these type of streaming pipelines with a modern tech stack, so there you need to maintain these kind of state management. You need to do these kind of state management, which will be done with the help of embedded database or even external database. So whatever data you are processing, intermediate data, you will dump there, and then when the next stream or the next event is coming into the processing system, you are looking at the historical values and then aggregating and then updating it. So this is how it is going to work. So this migration part here, we basically need to define that internal table which will be the part of embedded database. So in this lab environment, we are using SQLite as our embedded database. So in this .sql file, basically we will put that create table statement, and it will be only executed once, not multiple times, only executed once whenever first time we initiate our pipeline. Then the next file, which is this lambda expression, this is nothing, means our SQL logic. So the problem statement I was talking about, if I have to count how many times a user has visited a particular Wikipedia article, so obviously user ID should be the key here, and based on that I will write my logic in the SQL that if this user ID already exists in our metadata or this metadata table, then we just simply need to increment the visit count by 1, and we need to update the last modified date and the title of the modified article. That's it. So all those kind of logic basically we will be putting it in this file. So for our state management, this is going to be our table schema, which is users table, and it will have user, first seen, last seen, total edits and total lines, and this is our primary key. So this is the internal table which will handle and which will store all that aggregated data which we will publish to the downstream system after the processing. So we have created this DDL here. So after doing the complete analysis, once we execute this data pipeline, this table will be created internally for this embedded database for state management. Now coming to this lambda part where our actual logic should be present for the processing. So here this is going to be our logic. Let's break it down one by one and try to understand how it is working. So this entire processing, we all know that going to be on the streaming side. So there will be two things. If there is a complete new user, right, you are consuming that data for the very first time for that particular user. So we are maintaining that data in this state table. So we will do the lookup here, right? Means if the data for the incoming user is already present in this user's state table, if it is already present, then we need to just increment the values and we need to update it. And that is what is being done here. Insert into this table these column names. First we are selecting whether the data for that particular user or that user already made some edit previously, right? We check that part, and here we are using this statement on conflict. What we need to do, just do this update. So if that user data already exists in that state table, we need to do this update, means change this last scene to the date column which we are getting inside the meta object, and then total edits will be the previous edit plus 1. Similarly, total lines plus whatever is the collage value or the not null value we are getting based on this difference, or it could be 0, right? Because a user can simply come, right, open that article and do not make any changes and simply log out, right? So in that case, we did not made any line changes, so it should simply come as a 0. If there will be any difference, that number of line changes will be added in the previous one. And then we are simply selecting all those attributes where the change type was edit and the user was particular incoming user we are getting in the incoming event. So this is our entire logic which we have written here. So now you can even see how seamless this process is. So even someone who knows the SQL very well and do not have a good command on, let's say, Python, Java, Scala or that type of languages, still you can create these type of streaming pipelines just with the help of SQL. So our two major tasks are done: the main core logic for the processing and updates, and then this metadata part. Third important thing is this flow.yaml. So in this flow, basically we need to mention two things. First part, which we are already clear, like which is going to be our metadata or state table, and which one is going to be our SQL logic. Third thing, which is related to the incoming event schema. So here we need to mention that attribute or the column name from the incoming event, which will be used as a key. So as I already showed you here, that in our data, this user is going to be our key, and the same thing we will be mentioning here. So wherever it is written your key, so it can be replaced with that user column name, user, and same thing we will have here as well, and same thing we will have here as well, right? So this is done, and this is also done, and this is also done. One more time, save. So we are pretty much done here now. And now after that, it is just all about executing our pipeline and then dumping that data into the downstream system. So before executing this pipeline, we will do the preview, like how this output data is going to look like. So for that one, we can fire the command, these commands which are especially for this platform itself, because here everything is known as a flow. So we will be executing this flow using the CLI commands. So this is going to be the command in order to execute the flow, or basically to see the preview of this flow which we have created under this project. So let's hit the enter and see the output. So here you can see that how this data is getting generated, because it is consuming all the incoming stream data which was already available, because it is keep on coming. So it is keep on consuming and just keep on updating the data for each of the user, right? So you can see their encoded names, the total lines, the total edits, the last scene, the first scene, all of that data is actually maintained here. So this is how our output is going to look like in the preview. So sometimes what happens, let's say you are executing this flow for the very first time, it will ask you to authenticate based on the access token. So how you can do that? You can come back to the platform here, and you need to go to the admin, and here in the admin section you need to go to this CLI API, and here you will see your access token. So just copy that one, and if it asks for the authentication, just paste that access token and your access will be granted. And one interesting thing you can see here, that how continuously this data is keep on getting processed, because we are receiving that data. That is the actual visual picture of the streaming data pipeline, right? Where we keep on getting data in the real time and we keep on processing. So this is how it looks like. And now we can simply terminate this preview part, and after that we will execute this pipeline. So when we are saying that we will execute this pipeline, it is simply means that we just want to publish this flow, right? Whatever will get executed with the help of this flow, we need to publish the output, and that output, where it will go, it will again go back to the collection, because ultimately the incoming stream of the data we are getting and the output which we are getting generated, that will get stored on the S3 platform itself in the form of collection, because it's that intermediate data which needs to get published. So let's publish our final result. For that one, flowctl catalog publish -- source, and our source is going to be this flow.yaml, and just hit enter. So now here you can see this with this name, right? This collection will get created, and here it is asking enter y to publish. So hit enter y. So now it has started proceeding, and this data, the process data, will be available in this collection. All right, this publish is successful. We will go back, come to this collection. Here we should be able to see our data, which is Wikipedia data analysis, which we just created a minute back, right? So our final result is here now. So for this example, what we want this data to be available in the downstream system. From your side, you can have something else, but I would like to show you this interesting thing, that how you can make this data available in the Google Sheet itself, right? So let's do that. And for that one, what we will be doing, we will create this materialization part. So hit enter. Here, what connector we want to use? We want to use this Google Sheet. So this is how we can create the materialization, which will publish our data to the Google Sheet. Here we can give a name to it, final Wikipedia data results. And then another thing which we simply need the spreadsheet URL. Means first we should have a Google Excel sheet. I have already created it, and I will simply pick this URL and will come here and will paste it, so that this flow or this platform will basically have that access, or will have that destination to publish that data to Google Sheet. And if we want to allow this platform to publish that data, we need to authenticate as well, right? So let's do that authentication. And once this authentication is done, you will see this is how it will look like. And then we need to select that output, right? So this is going to be our output, means the output which was present in the collection, which we want to publish in the Google Sheet. So once this is done, let's click on the next button, and then it will ask to save and publish. Let's do that. And here it has started publishing this data. It will generate the logs. All right, so here looks like steps are successful. All right, so things are successful. Now close it, and here you can see this materialization final Wikipedia data result with this name. And here we will go back to our sheet, and here you can see one new tab got created, sheet basically Wikipedia data analysis. So let's click on it, and after expanding this data, this is how it will look like. Basically this is our value part, and this is our user, which is definitely the key, and corresponding data is published here. So all the values, first seen, last seen, total edits, total line, users, all those things are present here. We can verify here this user, and now this data is available for further consumption. From here, this can be used by another streaming platform or any other you can say downstream system which can have this type of JSON data, and then you can query it there. So this is how we saw that how easily we were able to create this data pipeline which did that Wikipedia data analysis and all the user level aggregation. And I know explanation for this video took time, but when we created this pipeline, it did not take much time, right? It was hardly few minutes to create, and that is the actual beauty of this SQL streaming. So I personally enjoyed it, and I think this is definitely going to be a game changer because of its adaptability, and it will definitely just reduce the development life cycle and will take off all those burdens of like challenges related to the streaming data pipeline. So I personally liked it. I personally enjoyed it. So now I want you guys as well to play around this project and build it completely and just flex it, add it in your portfolio and explore this platform a lot, because that is definitely going to be a game changer in upcoming years, and you will have all the idea beforehand. So why not to use it at this particular point of time? I will provide all those important links in the video description, and let me know your thoughts in the comment section. And if you find this video informative, make sure to give a likes in the big numbers. If you have anything to ask, feel free to put it in the comment section. And if you're new to the channel, then hit the subscribe button and press the notification icon. I will see you guys really soon with another amazing tech video. Till then, just keep exploring data.